This is my Tableau interactive control surface. It's a USB device originally designed to capture gestures for tabla drumming, where you use wrist motion and fingers. It turns out to have a lot more other gestural possibilities, but I'm going to demonstrate here how to actually build one, and in particular how the two major sensing techniques, piezoresistive fabric sensing and drape sensing, work. So let's look at the framework first. We've got a microcontroller, could be an Arduino, but in this case it's a CUI device because it's got 13 analog input channels and USB integrated, and Senmat's micro OSC software. And this board was already cut to this shape. It's used by potters to turn pots, and by a fun coincidence it's just the right diameter to trap this embroidery hoop, which I have conductive fabric. This is spandex plated with silver, and this drapes over a cereal bowl. The cereal bowl has Velostat resistive plastic glued on, and using lead conductive tape I establish a contact point for the fabric, and I pick off the bottom end of each resistor and wire it to the microcontroller. So the basic sensing technique is to use the fabric in the hoop to drape over and short out these resistive regions. So it's a way of translating position into a short and thereby measuring displacement. The second iteration of this has what a keyboard player would call aftertouch, and here I simply took some piezoresistive fabric from Ionics and cut it and placed it on top of some conductive copper fabric. And there's a similar patch at the top for a central pressure sensitive gesture. As you can see now, I've powered the Tableau up from USB. I'm illuminating some LEDs, and I've set these up to establish, might think of them as frets, to establish the regions of interaction.